This is a series of 2 in which we will be animating the robot that we decimated in the previous tutorial. We will look at the forwards kinematics mainly in this tutorial. The next one will look at armatures and bones. And what we will be creating is something like I show on the screen right here. Although it does include some textures in the animation that's up on the screen, that's something we will deal with in the next tutorial. And even though this is not a blend tutorial per se, I tried to list all the keyframes that I'm using in the tutorial, but just to give you some guidance, I'll put a whole list at the end of the tutorial if you're interested. But that's enough said, let's dive in. Just a short recap for the people that have been following along with the previous tutorial. I'm working with a decimated model that has, and let me turn on the statistics, that has about 40,000 triangles. So I decimated the individual objects by about 80%. So that's the first thing that you notice if you followed along with the previous one. The other thing that you notice is that the organization that I did into robots and lights, it's gone because I used a different model. I will reorganize this later in this tutorial, as that's one of the key aspects of organizing your scene. We're doing only one robot, so it's not that important for this one, but as soon as you start making multiple robots and conveyor belts and assembly machines, then you may want to organize your stuff really well, because it gets complex real fast. Okay, having that out of the way, let's jump right in. The first thing that we notice when we look at the model that we imported is that each of the individual parts have a certain rotation, and also they are scaled a factor 1000 too small, and that's due to the step model that we imported. We want to change the rotation back to 0 degrees on all the axes for each part, and the scale back to 1. And the way you do it is you select the part, you press Ctrl a menu pops up, and you're going to apply the rotation and the scale, and that reduces the rotation to 0 degrees and the scale to 1. Alternatively, you can select the part, go up to Object, and then select Apply and choose Rotation and Scale, which is the same thing. And you need to do it for each of the parts which are on the robot, so that we have a fresh start and we're not going to run into any problem when we export this to another program like Unity or Unreal, where the scale may be off or the rotation of the individual objects is wrong. So once you've done that, we are ready for the next step, so let's look at that. The next thing we want to check are the pivot points of the individual objects. For the axis number 1, you can see that the pivot point, which is located on the bottom, is even outside of the model. But more importantly, when it's placed incorrectly, like on this object, and I rotate it, you can see that it's rotating incorrectly. The pivot point is located here, and we should set this so it makes a correct rotation. Let me just clear this and get this back to a 0. And on the top, it's even more prominent. If I rotate this over the y-axis, you can see that's incorrectly. And if I just indicate, the origin point or pivot point should be right there on the flange. So we need to go through all of these individual parts and place the origin points correctly. For the base, it's not so important, so we leave it like it is. But for the first one, yes, it is. Let me isolate the part by pressing the forward key. And the way you can set the origin point is by tapping into edit mode by using the tab key. And then make a selection where you want the pivot point to be. In this case, we can either select the inner faces, which is a good approach, or we can select them here on the side. I find the inner faces to be a little bit more difficult, as it is very likely that you miss a small part here, which creates a small offset of the pivot point, And you can only find out when you're done with the animation and you have to go back. So we have to be careful. So I select the side part and I'm just gonna select all of these parts. And I find this the easiest to work. And in this case, the most secure. But you can choose the other parts as well if you find that more comfortable. Okay, so I have all the parts selected that make up the pivot point. I'm pressing Shift S and I say cursor to selected. So I'm using the cursor as a kind of marker. It's right dead in the center because I selected the outer rim, which is a circle. I'm tapping out of edit mode. I'm going all the way up, selecting object. Then I'm going to select set origin. And I'm going to say origin to 3D cursor. And there you are. And I got the part here. Let me just get this back into view. And if I rotate right now over the Z-axis, you can see that it's rotating correctly over the bottom part. And I can do the same thing for the second axis. And let me just isolate it for 1 minute. Let me just tap into edit mode and you can see I have a selection there already, which is incorrect. Let me just deselect this and I'm gonna select the part that I need. And right now I'm gonna select the bottom part. I think I can achieve this in a good way. I could have also selected the outer edge here or even the big circle here. I've chosen to use this one. And I got all the parts selected. So I'm pressing Shift S. The cursor to selected is right in the middle. Then I can press out of edit mode. Going up to object, set origin and origin to 3D cursor. And you can see now that the origin point is right in the middle of the flange. And if I rotate this over the Y-axis, you can see that the rotational point is placed correctly. And let me just get this back to 0, get this back into field view, and I'm gonna do the rest of it, but I'll speed it up a little bit. The next thing we want to check is the parenting of the objects. All the objects are individual parts right now, and that's something we can see in the hierarchy as well. All the axes, including the base, are all on the same level. But what I want is that this part moves along if I rotate the bottom part. So if I rotate it right now, then it's the only one that rotates. And I want this part to follow this and so on back to the 6th axis. The way I can do it is through parenting. So I'm going to select the second part. I'm going to select the master part. Then I Control P and I'm going to select Object Keep Transform. If I now select the axis number 1 and rotate over the Z axis, you see that the second part moves along. So I only have to rotate one part to have the other one rotate as well. And this is also something you can see in the hierarchy. You can see that the axis number 2 is gone, but actually it's listed underneath here. So it is a child of the axis number 1. And let me zoom out again. I can do the same thing for the third axis. So I select the third axis, then I select the master one or the parent one, Control P, and I say Object and Keep Transform. If I now were to rotate the Z axis, I got 3 parts that move along. So that's fine. But if I rotate the second axis over the Y, you can see that only the top one moves along, which makes it much easier to animate. And this is something I can do for all the parts. So I'm going to select the fourth axis and then the parent one, say Ctrl P and object keep transform, and number 5 together with the axis number 4, then Ctrl P and keep transform, and the last one, and back to the fifth one, Ctrl P and keep transform. And now when I rotate any of the parts, the one in front of them are gonna be rotating along. And now we have something which is actually called forward kinematics. So if I move one part, all the ones in front of it will move along. And this is something we can now see in the hierarchy as well. So the part axis number 3 is part of axis number 2, and I got a whole flowchart here of axis 4, and they're all parented together right now. And this is something I can use to create an animation. Now may be a good time to start organizing our work a little bit. So when you look at the right hand side, we have 2 collections, which are a type of folder in which you can store information. On the top one, I put my camera and my light. The second one is empty as the robot parts are outside. Let's first rename the top one to lights. So we put everything that belongs to the lighting in this folder so we can use it later on. And the second one is the robot folder, like so. Now we want to place all the parts of the robot inside of this folder. How can you do it? The easiest seems to be just by grabbing this axis 1, for example, and placing it inside of robots. But it will only place the axis 1 inside, not the axis 2. They will remain outside. So all the children of this parent remain outside of the folder. And let me just undo it. One quick way you can do it is, let me zoom out. Just go into the viewport, select all the parts that you want to move. So I move select the entire robot that I want to move. Then you see everything is selected in the hierarchy on the right hand side. I pick it up and I move it up so it turns black at the robot. So that's the one selected, and I let go of the mouse button. And now everything is inside of the folder. And if I want to take it out of the folder again, I just hold my mouse button down. I drag this up into scene. I let go. And all the parts of the robot are now placed outside of the folder. And this is a good way to organize all your models and your scenes. Or what you can also do is select all the parts that you would like to move into a specific folder. Select them all. Press the M button while you're still on the viewport. Then select the folder where you would like the objects to move to, in our case robot. And if you now look at the hierarchy, you can see that all the parts have moved inside of the robots folder. If you would like to move them out of the folder again, go back to the viewport, pressing the M button again while all the objects are still selected. Then select scene collection, which is the root folder, and in that case we placed everything outside of the folder. And this is a good way to organize all your models. But before we start animating this robot, let me give you a little bit of background on how animations work in Blender. The basic animation starts with a start point, usually at a frame 0, so time 0. Then you move in time, usually over frames, 24 frames per second in default in Blender. So we got the time on the x-axis, and then you go to a different position for location, rotation and scale. That's the second point. And then through the method of interpolation, the distance or the path between the 2 points is determined. In Blender by default it's a Bezier curve, and I put a straight line as a reference, which is a linear interpolation, and that's how the path between the 2 points over time is determined. So let's create an animation, and to make it a little bit more interesting, let me just put a little cube. Let me just get a cube. Let me just scale this down and have the robot touch the top of this cube. And I'm just gonna place the cube at some weird location. Let's do it like this. As about, I think this is fine. Or maybe, okay. So what we want to animate is, and if I take a side view, you see the cube is on the floor, and we want this robot to touch the top of this cube. And we're going to create an animation for it. Let me just pull the bottom up a little bit so we can see the timeline here. And the first thing that we want to check, and we go to the output properties, and the frame rate is specified. Let me just zoom in right here. And by default, it's set at 24 frames per second, but we can use this pull down menu to look at the other options. The different frame rates are listed here, including custom. You can set your own frame rate, but let's use 25 frames per second, which makes the calculation a little bit easier. And let me zoom out again and get back to the timeline. You can see that we have 250 different frames, which is 10 seconds of animation in this case. This is the timeline. We can scrub through it. So let's create an animation. And the way you do it is you set the base point. In this case, this is where we want to start. You press the I key and we're going to select a location, rotation and scale. And the first thing that you notice, obviously, is the yellow background here. And this is an indication that the location, rotation and scale have been animated. And in Blender, this is shown as the yellow background. And let me just clear this. And you can also see it on the bottom. And this is the first keyframe. And that just fixes the location, rotation and the scale. So we want this to move to a certain location, and first we're gonna define how long it can take. And let's just take 100 frames, which in our case is gonna be 4 seconds of animation. And we want this to rotate. Let's take the other direction and let's go to about, and I think it's about minus 30 something, which is about right. Then I'm gonna press the I and I'm gonna confirm location, rotation and scale. So what's happening now is that from the time 0 to time 100 or 100 frames, 4 seconds, the robot is going to move from 0 degrees to 30 degrees. And if I scrub through the timeline, you can see this movement like so. That's the first one. Let's do the second one as well. Let's start this exactly when the first one has stopped. So we're going to confirm this location right here. Location, rotation and scale. I confirm it. And that's shown as everything is yellow on the right hand side. And I see the keyframe. Now I am going to define the endpoint. Let's say I'm going to take 70 frames. So from 100 to 70. And I'm going to rotate this over, say, I think minus. It's about this. It's a little bit over. Yeah, I think that should be right. And I'm confirming the location, rotation and the scale. And now I got my third part. And let's have this start a little bit earlier. So at 140, I am confirming the position of this point. And let's make this really, really slow. And I'm gonna end this animation at frame 250. And this is going to be in the Y as well. And I want to touch the object. So just on the top of it. And I think I got it right there. Yes. And I confirm this. And if I would play the animation right now, you can see that the bottom part first rotates. Then the second part comes in. And the third part rotates as long as the second part is rotating as well. And there it touches. So we have created the first animation. That's fine. Maybe you want to make some changes, and that is actually quite easy to do. So the first part is rotating over 100 frames. Suppose I want this to be a little bit slower. I have to deselect everything. I can grab this keyframe, press the G key, and I can move this to 150. And now it's going to take 150 frames for this axis 1 to rotate. So if I would play the animation right now, you can see it's much slower, and the second animation starts already and then it touches it again. So I can make this very fast to have this animation, which sounds very nice, but there's one little problem which may occur. If somebody would say, or you want to move this little cube to another position, for example right here, then I would need to reanimate this part, the second part and the third part as well, which may involve a lot of work, especially when things are moving along and I need to pick up like 3 or 4 of these cubes or want to touch them on the top. And that is going to involve a lot of work and a lot of keyframing, changing it, verifying them and doing this again. And this is where the inverse kinematics will come in very handy.